Welcome to Brain Vision.
So if we want to find the surface area of this cone, the first thing we need to do is find the partials, and then once we have that, we can try to figure out this region D. But since, notice, these two um, surfaces we have down here are only in terms of y and x, we could just think of this in the xy plane, which is essentially what we would consider to be our region D. So we need to figure out some way to kind of write this out. Yeah, we'll come to that once we actually get all of this up here done first, though. So the first thing we need to do is find our partials with respect to x and y. So let's do that. So remember, this is really to a 1/2 power. So when we take the partial of this with respect to x, so this gives us del z by del x is equal to, so it would be 1/2 x squared plus y squared raised to the, not 3/2, negative 1/2. And then we have to take the derivative of the inside, assuming y is a constant, which would be 2x. So these 2's cancel out with each other, and we can go ahead and write this, it looks like, as x over x squared plus y squared square rooted. And now, notice since this is like symmetric, we can actually just use, not del z, but del y. We can just use the idea if we were to switch all the variables in this derivative over here, we should get the same answer for when we take the derivative with respect to y. So if you were to go ahead and check this, you will see you'll end up getting y over the square root of x squared plus y squared. And so again, anytime you have like this symmetry going on, or like if you can interchange the variables and it still gives you the exact same equation, because y squared plus x squared is the same thing as x squared plus y squared. You can just use that to help you find the derivatives a lot faster. So I'm just going to do that. So actually, let's go ahead and plug this into here real fast. So this is going to be the integral over this area D. And then we have 1 plus, so if I square the partial of x, that is going to be x squared over x squared plus y squared. And then plus, if I do the same thing with y, it's going to be y squared over x squared plus y squared. And then all of this is square rooted. Now notice since these have the same denominator, we could actually go ahead and write this as one fraction, and it would become x squared plus y squared over x squared plus y squared. So this whole thing just becomes 1. And then we're going to have the integral over the region D of the square root of 1 plus 1, or 2. So now we need to figure out, well, what is this region here? So let's go ahead and do that. So let me sketch this first. So we have y is equal to x. So I'll just kind of do like a quick sketch of this really fast. So I'll write it up here, y is equal to x. And then we have x squared, which looks something like this here. So the region we're interested in is going to be right here. So if we were to think about how we would describe this region, first we can think about how y varies. So if I start below the region and then I pass through it, notice I first pass through the green line and then I pass through the blue line, which would mean the upper bound for y is going to be x and the lower bound for y is going to be x squared. And now for us to figure out how x varies, we need to figure out what are these 2 points here. So we would just set x equal to x squared, then subtract over. Then we can factor. So x is equal to 0 or x is equal to 1. So our bounds for x are going to be from 1 to 0. And now we can go ahead and plug these in and then finish our integral. So this is our region D. So x will be on the outside since it's just constants. Y will be on the inside since we have those variables. And then we have root 2 dy dx. So now if we integrate root 2, well, that's just a constant, so it would be, actually, let me do this in blue to make it stand out. So it would be root 2y, oh, not root y, root 2y evaluated from x squared to x, which, since we just have a constant there, would just be x minus x squared. So this would be the integral of, and actually I'll pull that root 2 out. So root 2 integral from 0 to 1 of x minus x squared dx. And then to integrate this, we use power rule. So root 2, and then we have 1/2 x squared minus 1/3 x cubed, evaluated from 0 to 1. So we plug in 1, that gives us 1/2 minus 1/3, and then when we plug in 0, that just gives us 0. So 1/2 minus 1/3, so that would be 3/6, 2/6, so that would just be 1/6. So that would be root 2/6. And so this should be our surface area.